In Chapter 14, you're being introduced to chi-square tests, which are non-parametric tests. Now, if you're still not sure what non-parametric tests are, before you watch this little video clip, go back to your textbook and read the little section about non-parametric tests and how they differ from parametric tests. So, chi-square tests that we're going to be reviewing, there are three different types. The first one is the goodness of fit test for known proportions. The second one is often called the goodness of fit for similar frequencies. And the third one is the chi-square test of independence. So let's start with the chi-square goodness of fit for known proportions. Now, the chi-square goodness of fit test for known proportions is used to evaluate the frequencies that you've observed and determine whether or not frequencies you've observed differ significantly from known frequencies in the population. Now, just to recap, chi-square tests are used to ask questions about observed frequencies. What we are looking at are head counts, the numbers of people that occur in each of the categories that we're interested in. This is very, very different from evaluating, for example, a mean motor reaction time for three different groups and comparing the mean values. These are two entirely different things. So chi-square tests are used for this type of a problem. So here's the situation. In the population, that is all of undergraduate students in the United States, let's just imagine that it's been reported that across all universities, that is the population of undergraduates, approximately 30% of students major in business-related areas, approximately 25% major in science and technology-related areas, and approximately 45% major in liberal arts-related areas. At your university, you have sampled 100 students, N of 100, and you've observed that in that N of 100, 30 out of 100 students have reported majoring in business-related areas, 40 of the 100 have reported majoring in science and technology-related areas, and 30 of your 100 have reported majoring in liberal arts-related areas. So you want to know whether or not the observed frequencies at your university differ significantly from the known population proportions that have been previously reported. Now, we've done something here. In the population proportions are oftentimes reported in percentages. And so you need to convert those percentages to expected frequencies for these columns based on these percentages by simply multiplying times the number of observations in your sample. So if 30, you take 30% is the known proportion in the population, for example, in business-related areas, you take 0.30 times 100 because 100 is the number in your sample, and you get to an expected frequency, right? So you can see that just by eyeballing the data that your expected frequency for numbers in business match exactly the proportion that would be expected, right? However, in science and technology, it looks like there's many more, proportionally more students majoring in science and technology areas and fewer majoring in the liberal arts. And you can see that just by eyeballing your raw data. However, you don't know, without doing a non-parametric test, such as a chi-square test, whether or not the observed differences are statistically significant, or whether or not this amount of difference would just be expected by chance alone. So that's what your chi-square test is going to help you with. All right, so here's the chi-square test for known proportions. It's very simple. As you know, in the steps before you got to this point of calculating the chi-square test, you determined your chi-square critical value using the table for critical values for chi-square distribution, and we're using 0.05, and we have a right, and so your chi-square critical value is 5.99, and that's for chi-square with 2 degrees of freedom, right? So now we just calculate through, we plug in our numbers, and I've written this out already. You see that in the first category for business, I have frequency observed is 30, frequency expected frequency observed is 30, frequency expected is 30. 30 minus 30 squared, of course that's not necessary to do, that's 0, right? And then for the next column we have 40, for the next part of the formula, 40 minus 25, right, squared, divided by 25, because that's the expected frequency, and then we have 30 minus 45, and that difference squared divided by 45, which is the expected frequency. So let's just calculate this through quickly. So we know that this one is 0. Okay, and here we have 15 squared, which is 225, divided by 25. And here we have also 15 squared, which is 225, but this is divided by 45. And if we go ahead and calculate this through, 225 divided by 25 equals 9. And 225 divided by 45 equals 5. Right? So for this little problem, our chi-square value is 14. Our critical value is 5.99. The absolute value of chi-square in this case exceeds the critical value of 5.99, and so we would say that there is a statistically significant difference in the frequencies of students at your school and the frequencies of students in the known population who are majoring in each of these areas. Now, of course, you always have to return to your raw data and examine where do the differences lie. And in this case, the differences obviously are in science and technology and liberal arts, because those in business are exactly the same. That's an example of the calculation for chi-square goodness of fit for known proportions.